Hey, welcome to the Explainer. Today, we're going to decode three simple but kind of profound rules that basically run our entire universe. Everything from a rolling ball to a planet whizzing through space. Yeah, you guessed it. We're talking about Newton's laws of motion.
So let me ask you something. You've been there, right? You're on a bus, just minding your own business, and the driver suddenly slams on the brakes. And you kind of keep going, lurching forward. Why is that?
Or think about this. How in the world does a gigantic, heavy rocket actually get off the ground and just launch into the sky? And what about something as simple as swimming? You're pushing water backwards, but you move forwards. How does that work? Now, these three things, the bus, the rocket, the swimmer, they seem totally random, right? But believe it or not, they are all connected by the exact same secret.
All right, so here's our game plan. We're going to look at the guy who cracked the code. Then we'll tackle his three big ideas, what I like to call the rule of laziness, the rule of force, and the rule of pushback. And then we'll see how you can spot all this stuff happening around you, like all the time.
So, the man behind the curtain, the one who connected all these dots, the one and only Isaac Newton. And honestly, calling him just a scientist doesn't do him justice. He was more like a master detective, uncovering the clues of the physical world. So Newton was born back in 1643 in England, and he was just super curious. You know the famous story, right? The one with the apple falling from the tree? Well, whether it's totally true or not, the point is, most people would just see an apple. Newton? He saw a puzzle. He asked, wait a second, why did it fall down? Why not up or sideways? And that one simple question, well, it changed everything. It sent him down this incredible rabbit hole that led to him figuring out the basic rules of how things move. Okay, so let's jump into the first piece of this puzzle. It's his first law, officially called the law of inertia. But honestly, I think the rule of laziness is a way better name for it. So the official textbook definition goes something like this. An object will stay put, or if it's already moving, it'll keep moving at the same speed and in the same direction, unless some other force comes along and messes things up. But really, what does that mean? It basically means things are lazy, physically lazy. They want to keep doing exactly what they're already doing. If something is just sitting there, it's going to stay sitting there. If it's cruising along, it's going to keep cruising along. You need to give it a push or a pull, a force, to change its mind. And boom, that solves our first mystery, the bus. When the bus hits the brakes, the bus stops, but your body, because of inertia, wants to keep right on going. And that's the lurch. It's the same exact reason a soccer ball just sits on the grass until you kick it. Or why if you stop your scooter real fast, you feel like you're going to fly over the handlebars. It's all just inertia at work. Okay, so that's what happens when there's no force. But what happens when you do apply a force? Well, that brings us to Newton's second law. It's officially the law of force and acceleration, but let's just call it the rule of force. Now, the textbook version says that the force acting on something is basically a combination of two things. First, it's mass, which is just a fancy word for how much stuff it's made of. And second, it's acceleration, how fast you make it speed up or slow down. But let's be real, it's just common sense, isn't it? If you want to move something, you gotta push it. And the heavier it is, well, the harder you have to push. Simple as that. And all of that thinking gets packed into this one tiny, super powerful formula. F equals m times a. Force equals mass times acceleration. Seriously, this little equation? It's a giant deal in physics. It's like the secret recipe for how everything moves. We use it for everything from designing safer cars to figuring out how to launch a satellite into orbit. And that m for mass is the key. Just think about it this way. Pushing a bicycle is easy, right? It has low mass. You don't need much force to get it going. Now, try pushing a truck. It has a huge mass. You'd need a ton of force to get it moving at the same speed. See? Different mass, different force needed. All right, on to our last clue. This is the one that really explains the nature of pushing and pulling itself. It's the third law, the law of action and reaction. Or, my personal favorite, the rule of pushback. And this one, it's just so elegant, almost beautiful, right? For every action, there is an equal and opposite reaction. It's like this perfect cosmic rule of balance. So what does that actually mean for us? It means you can't push on something without it pushing back on you. It's a two-way street. Forces always come in pairs. So if you lean against a wall, guess what? That wall is pushing back on you with the exact same amount of force. Crazy, right? And this right here,
This solves our other mysteries. Think about swimming again. Your hand pushes the water backward. That's your action. The water's reaction? It pushes you forward. It's that simple. And a rocket launch? It's the exact same principle, just way more extreme. The rocket shoves super hot gas down. That's the action. And the gas shoves the rocket up with equal force. That's the reaction. And that's how it gets to space.
Okay, so we've got these three laws. But the really cool thing is that they aren't just three separate rules. They all work together, like a team, to explain pretty much any kind of motion.
Let's just take riding a bike. Think about it. First, the bike is just sitting there. It's not going to move on its own. That's the first law, right? Inertia. Then you have to apply a force. You start pedaling. And the second law tells us that the harder you pedal, the faster you'll speed up. Simple enough. But how does pedaling even work? That's the third law. Your foot pushes the pedal down and back. That's the action. And the pedal pushes back on your foot, which turns the crank and moves the whole bike forward. That's the reaction. See? All three laws in one simple activity.
So, look, if you take away just one thing from all this, make it this little cheat sheet. First law, inertia. Basically, you need a push to get going or to stop. Second law, force. Heavier stuff needs a bigger push. And the third law, action-reaction. Every push gets a push back. Got it?
So there you have it. 3 simple laws figured out by one incredibly curious guy that completely changed how we see everything. And it all started with him just asking a simple question about something he saw every day. So I guess the question for you is, what's your falling apple? What's that ordinary thing you see all the time that maybe, just maybe, you should stop and ask why?